First of all, I have to say hello to everybody that participate in this seminar. And I hope that this seminar will be useful for you. And I try to make a connection between two subjects. One subject refers to fuzzy optimization, and another subject is related to machine learning. And I try to make a connection between these two things, and hopefully you will be able to understand anything about these two subjects, two separate subjects. And first of all, of course, I have to appreciate Hussein for introducing me. And again, I am Bahram, full professor in Ph.D. University in Iran. And I am working on some fields related to applied mathematics, concentrating on optimization. And most my article is centralized on fuzzy optimization. And the main major of me is related to fuzzy optimization. But in this session, I try to make a connection between machine learning and fuzzy optimization. If you want to define in some brief sentences machine learning topic and fuzzy set concept, we have to say that machine learning is a technique that used to extract interesting pattern from some data and predict. And another side, in other side, what is fuzzy set? Fuzzy set is a way to show, to represent uncertainty. There is a difference between showing uncertainty in fuzzy set and in other subjects like statistics. That's referred to this point. For example, if you consider cloudy weather, when you see the weather, the sky, maybe you observe some cloud. And if you want to judge about the cloudness of sky in crisp viewpoint, you can say that this weather is cloudy or not. Because in mathematical concept, we have two values for judging about some things. 0 if this is not, and 1 if it's complete. But in real world, we cannot say, for example, the sky is cloudy, absolutely, or is not cloudy, absolutely. So there is a uncertainty between our interpretation of the sky, and therefore we need to judge about this phenomena by some value between 0 and 1. For example, the sky is approximately cloudy, the sky is near cloudy, and etc. Therefore, fuzzy set plays the main role in this situation when we are not able to judge about something exactly this is true or false. However, let me indeed introduce machine learning to you. Of course, all of you know completely about machine learning and and its partition and its division, but I need to speak about these types of machine learning and this partition of machine learning, because I need to merge this concept and this subject with my basic major. Machine learning is divided to two methods, two viewpoints. One viewpoint is related to supervised learning, and another related to unsupervised learning. What is the difference between these two things? When you want to label the data, when you want to say some things about data sets, you can label some data set, and you can judge about the data sets without labeling. If you use label data set, you are using supervised learning. And when you are not certain about the data, and you need to deal with unlabeled data set, you are concentrating on unsupervised learning. Therefore, we can divide the machine learning subject in these two categories. What are the branches of supervised learning? Again, you can divide supervised learning methods and supervised learning algorithms to two subgroups, like regression or classification. Regression is used to understand the relationship between independent and dependent variables when you are facing to a problem. And there is some related methods in this area, like linear regression, logistic, and polynomial regression that you name and that you recall these methods. And classification, you need to assign the data, the test data and the experimental data, to some specific groups or categories. In fact, you want to classify the data in some groups or categories. The noun methods in this category is linear classification, support vector machines, and decision trees, and etc. The main things that we have to speak about that, and we have to discuss about that, is unsupervised learning. When a human cannot judge directly about some phenomena. This is related to unsupervised learning methods. This kind of technique is divided to dimensionality reduction, association, and mainly on the clustering. What is clustering method? Clustering method is used for grouping on labeled data. Based on what? Based on similarity and differences. This is the main point of thinking, or point of describing a phenomenon by fuzzy set, because this is the trade of fuzzy in this subject, you know. similarity and differences. And in this session and in this seminar, I'd like to speak about this kind of optimization, this kind of algorithm. If I would like to describe briefly clustering algorithm, I have to mention some items like pattern, where we are decide on this, attribute, we judge about pattern based on this, and we have to get together or make a group with similar thing in a cluster, a similar property in a cluster. Until this time, if there is a question, I would like to hear and discuss about that. And after that, I try to present the main body of this seminar. Is there any question? Okay. So I continue my presentation. In real world, we have two viewpoints. One thing is related to CRISP clustering algorithm. CRISP means you make sharp the boundary of accepting some things or unaccepting some things. I mean that you assign 0 to some phenomena or 1 to some phenomena. But in a real world, as I explained to you, the cloudy sky, you cannot judge about anything exactly by 0 or 1, and you have to select some value between 0 and 1. This is the point that we have to use, and we have to implement fuzzy theory. Therefore, I am intend to speak about and discuss about fuzzy clustering algorithm in the next slides. But as I said, that clustering means making some pattern in a group. In which group? The group with same property. Therefore, we need to use some criteria, some things like information measures. Information measures can include that distance measures, similarity measures, and entropy measures. What is the distance? All of you know that distance is used to evaluate the dissimilarity of patterns. But what is the similarity? Similarity is a complement of distance. It means that it's used to evaluate the similarity of patterns. And entropy is used to describe fuzziness degree of some things. You mean that a phenomenon is uncertain, and therefore you want to judge about the uncertainty. In this case, you need to use entropy measure. In order to discuss specifically, I try to make a presentation briefly on my article, on my article that was published in Information Sciences. In this paper, as you can see, the title of this paper is Information Measures for Hesitant Fuzzy Sets and Interval Valued Hesitant Fuzzy Sets. Before discussing, you need to know the concept of hesitant fuzzy set. What is the concept of hesitant fuzzy set? In the sequential discussing, I will refer to that as HFS. It is abbreviated of hesitant fuzzy set. And let me define about hesitant fuzzy set at the end of this seminar, because maybe we need to discuss about anything in more detail. Therefore, I postpone the definition of hesitant fuzzy set. And at the moment, I am talking about the body of this paper. If I want to divide this paper into two main bodies, I have to say this paper includes theoretical body and application body. Theoretical body is assigned to finding and investigating the relationship between entropy, similarity, and distance measures. How we can, for example, transfer similarity to entropy, entropy to distance, and distance to entropy. And I approved in this article this relationship between these criteria. But the main part of this article that I want to speak about that, and maybe it is interesting for you, is related to experimental body of this paper. In this experimental part of this paper, I use clustering algorithm. I explained to you about the clustering, but here I'm going to speak about clustering algorithm in fuzzy context. Totally, clustering algorithm can be performed in 3 steps. Step 1, we first specify a set of alternatives by A1 to AN by the use of HFS. And then constructing the similarity measure, similarity matrix. The matrix in which each array is assigned to similarity between these alternatives, AI and AJ. After specifying the similarity matrix, we make and we construct the composition matrices. The composition matrices can be calculated by composition operator between 2 similarity matrices that I can explain thoroughly about this procedure by the use of 2 operations, max and min. You can consider, for example, if you want to multiply 2 matrices, you select the first row and multiply that in the first column. How you can calculate this procedure. You multiply each array of the first row to each array of the first column, and then put together by addition operation. Instead of addition and multiplication, you can use max and min. Okay. Therefore, you can get a result in form of composition matrices. We continue this composition operation until we reach this relation. C2k is equal to C2k plus 1. After getting that result, we stop and we say that we find the equivalent similarity matrix. Which is this equivalent similarity matrix? C2k. We say that this is a equivalent similarity matrix. And after getting that, we are in a position to classify all HFS's AI by lambda cutting matrix. What is the lambda? Lambda is the confidence level. By the use of that algorithm, I tried to find a solution for the problem that I stated here briefly. Consider you have 5 different kinds of software, for example, A1 to A7. 7 softwares, A1 to A7 on the market. And then you want to cluster these softwares according to the criteria, according to the attributes, like X1 functionality, X2 usability, X3 portability, and X4 maturity. For getting a decision, you need to invite several experts with different background, with different idea. These experts return their idea about these alternatives A1 to A7 according to this criteria or according to these attributes. For example, the expert A1 return his evaluation or her evaluation about the functionality by this number, 0.8, 0.85, 0.9. This is in fact a hesitant fuzzy element, a part of hesitant fuzzy set. What does this mean? This means that A1 is not certain about the functionality of some things. Therefore, he is hesitant. He's hesitant about some things, and he returns 0.8, 0.85, and 0.9. After getting the decision matrix like this, we evaluate the C matrix. What was C matrix? C matrix includes of arrays in which each array is a similarity between AI and AJ. If we evaluate and if we compute C for this matrix, for decision making matrix, we reach to this matrix. In each array, you have to focus on this. This is a similarity calculation of AI and AJ. By composition, if you composite matrices, you can find C4 is equal to C8, and you find this matrix. According to this matrix, you are now in a stage then, that you can judge about classification, about clustering the alternatives. If you set, if you consider lambda between 0 and 0.7842, you can see that by this value, by this variation of lambda, all the alternatives lie in a specific cluster. And if you change, this is according to this. For example, if you consider this data, you can observe in the second, in the third column, it means that A1 is related to A3, A2 is related to A3, and A3, and etc. Therefore, all of these alternatives are related together. And all of this for this lambda lie in this set. It means that they have a same classification. If we set lambda between this value, and if you change the lower bound and upper bound until 1, we can specify this clustering. Therefore, we can cluster all the alternatives by this manner. Of course, because of the limited time, I don't mention about the pool contents. And if you are interested in this regard, you can refer to this paper and find whatever you need. The main references that I use for this seminar is my paper by this, and all the kinds of hesitant fuzzy set you can find in this book that I have recently published in Springer. And another references are this. You can refer to them and find more about this. But this is a new field in optimization, especially in fuzzy optimization, that you can connect between fuzzy optimization and machine learning. This is a special branch, and you can talking about that, and you can thinking about that and find the solutions. Also, some references maybe are useful for you to find about this matter. Thank you for your attending in this session, and I hope that this session may be helpful for you, and I'm interested to listen any question maybe in your mind. Thank you.